behind that jacket someone has left behind. But it tells you kind of like the framing method for tangent. And on Friday in class, we kind of highlighted some of the big differences from tangent compared to sines and cosines. And if I were starting a tangent graph, I would really want the same 3 pieces of information to build my frame that I used to find for sine and cosine. However, there's one big difference. I used to find amplitude, period, and starting point. But remember we talked about on Friday, tangent doesn't have amplitudes. The amplitude is defined as half the distance from the min to the max. And we noticed that tangent doesn't have a min and a max, so it doesn't really have an amplitude. Okay. I still want to know that value though, because that's going to help be my vertical spacing for my tangent graph. So I'm going to, when I start tangents, and also we're going to do cosecant and secant, which don't have amplitudes today. I'm going to do those 3 things. I'm just not going to call A the amplitude anymore. So the only graphs you've ever graphed that have amplitude are those 2 wave graphs, sine and cosine. Okay. The other graphs don't technically have an amplitude. Okay, what is the absolute value of A? 1. This is a good one to know. Remember that A is the thing that gets multiplied by your tangent. So our A value is really that -1 that's being multiplied in front of the tangent. What is that, 2? That's really your D. All of our general forms can be written with the plus D at the end, or D plus all the stuff at the beginning. So that's just something to kind of like keep your eye out for. If it's not being multiplied by the trig ratio, it's a D, not an A. Okay, so our absolute value of A is 1. We talked about on Friday, we got to be really careful with a period because tangent only takes how long to repeat itself? Pi units. So instead of doing 2 pi over b, we're going to change it to pi over b. So in my notes, I'm going to show pi over b. That's pi over 3. Can't simplify that, so my period is pi thirds. Okay, starting point. If you look back at the blue notes, starting point is still the same. Now there's a difference of where we place the starting point in our frame, but we still do C over B comma D. So what's your C value? 0. There is nothing being subtracted or added with the BX, so 0 over 3 is going to be 0, and our D, of course, is that number out front, so our starting point is 0, 2. Process is the same. We want the same 3 things. A is for the vertical spacing. The period is going to help us with our horizontal spacing. We need to know where the starting point is. Be careful with your period. If it's a tangent, or if it were a cotangent, it would be pi over b instead of 2 pi. Let's draw a frame. If you're flipping back to the blue sheet and you look down at the bottom, there's a big difference in the frames for tangent. The starting point always used to be in the middle on the left. Now we're actually going to put the starting point in the middle, right? So we're kind of changing the view of the coordinate plane. That's because we have those asymptotes. So we're going to put our starting point right in the middle. I'll use an open circle for starting point of my frame. So that point is this 0, 2. So the x, the horizontal is 0, the y, the vertical is 2. Okay, that's going to be our C over B comma D, right in the middle. Build your frame vertically with your spacing A. So go up 1 from 2, you're at 3, down 1 from 2, you're at 1. And then I'm going to use my spacing method for the period. So for the horizontal label, I'm going to take my period pi thirds, and I'm going to multiply it by 1/4, because it's already a fraction. So my spacing should be pi 12ths horizontally. Now normally we would have had an x over here on the left, and we would have just added that spacing 4 times. The difference is we've labeled that x in the middle, so we're going to add the pi 12ths 2 times on the right. So 0 plus pi 12ths is pi 12ths. Pi 12ths plus pi 12ths is 2 pi 12ths, or pi 6. That's only half of my period. I subtract that spacing on the other side. So 0 minus pi 12ths will be negative pi 12ths, and negative pi 12ths minus pi 12ths will be negative 2 pi 12ths, or negative pi 6. Some of you are going to see on your quizzes that I hand back at the end, like you have a frame, and I'll take like your pi 6 and your negative pi 6. And if you notice that I write something like this, I draw a bracket and I do pi 6 minus negative pi 6. And then I say that's 2 pi 6 or pi thirds. Whatever I got when I subtracted your numbers on your quiz, it doesn't match your period. So that means like you don't have the spacing right if it doesn't equal your period in a frame. So if you notice that, okay, that's what that means. Any questions about building the frame? How it's different? Okay, the rest is just like, you gotta know the 2 shapes, right? They're kind of like the parent graphs. So the frame that we're looking through has asymptotes on the left and the right for the tangent. So I'm going to go ahead and draw those in. And then you can have a tangent that rises from left to right, so increasing, or falls from left to right, is decreasing. What should our tangent be doing? Increasing or decreasing? Decreasing. What tells us that we will have the decreasing tangent? We got that negative a, right? So it's the reflected one. So the starting point, we do cross through the middle. So this 0, 2, that is a point on our tangent. And then we want to decrease from left to right. So pi 12ths and 1 is a point on our tangent. And then negative pi 12ths 3 is a point on our tangent. Now on the quiz on Friday, I had like stuff on the side like amplitude, period, and starting point. And then I also had like domain and range for sine and cosine. If it's tangent, I'll have asymptotes and range for you. Okay, or I'll want asymptotes and range from you. Here's the benefit to figuring out your frames. If you've done all the work for the frame, the asymptotes are really easy, right? It happens at negative pi 6 and positive pi 6. Since they're vertical asymptotes or vertical lines, we write those as what? The equation starts with x equals. So make sure for your asymptotes you have x equals pi 6, x equals negative pi 6. And then for range of a tangent, all real numbers. It's a smooth curve, connected all the way. One side's falling, one side's rising. Negative infinity to infinity. Use your interval notations. Okay, recall. I will not ask you about domains. I'm not sure if I did this in our notes on Friday or not, but there is a way to talk about domain. I'm just going to write it on the board. If you came from Algebra 3, you maybe did cover set builder notation. So we have a way to write how to like skip all these asymptotes. If we're building that, and I won't ask you this, but this is just kind of good for you to see. You could pick any asymptote as like your starting asymptote. So I'm going to pick pi 6. My domain could be pi 6 plus, and then I would figure out like what's the spacing to my asymptote. Well, it's a full period, right? Pi thirds. So every pi thirds I'll get a new asymptote. So I can say pi 6 plus pi thirds k. And then I might also clarify what I mean by k, where k is in the set of integers. It's like a double-sided z. So that means like k can be positive 1, 2, 3, 4, can be 0, can be negative 1, negative 2, negative 3, negative 4, and those are like how many periods you would be adding on, but there will be an asymptote every time you do that. So this is how mathematicians would describe to someone where all the asymptotes will be. But I won't ask you that because we haven't covered set builder notation. Okay, any other questions you want to ask me on graphing a tangent? Okay, then we have left cosecant and secant. So I'll only ask you tangent graphs. Cotangent is very similar to tangent. The difference is the cotangent with the positive a is the decreasing, and the cotangent with the negative a is the increasing, but they sort of have the same shape as tangent, so it just looks like a reflection. Okay, but I'll only ask you the tangents. You only have to memorize one of those. But I will ask you cosecants and secants. So on this slide, I guess I'm kind of creating what I would call like the parent graphs for cosecant and secant, although I'm not going to go to as much trouble as I did for my parent graphs with sine and cosine, which is like labeling all the parts of the frame. Because this would be true with like any of the transformations, left, right, up, down, stretches, shrinks. We would just be changing the numbers on the outside of the frames, but we'll get the same pictures. So on the left, I'm going to draw a cosecant. And on the right, I'm going to draw a secant. But when I'm drawing these, I'm really going to build off of what I know about their reciprocal functions, which is they come from sine and cosine. So I'm going to lightly sketch. This is not part of the cosecant graph. I'm going to lightly sketch a sine, mountain high, valley low. And over here for secant, I'll lightly sketch the cosine. Remember, starts and ends at its max. So those aren't actually part of the reciprocal graphs, but I'm going to use them to help me form what my graph actually looks like. Notice for these reciprocal functions, like we're going back, our starting point is back over on the left, right? It looks like the sine and the cosine graphs. So all that stuff goes back to the old way that we would do it. If you want to find the period for cosecant or secant, it's going to be 2 pi over b. So it's only tangent that is pi over b. Okay. Well, cosecant is the reciprocal to sine, right? 1 over sine x. So this green curve represents the y values of the sine function. So like whenever you're at the midline, even if you have transformations, when you're at the midline of these graphs, this is the place where your function equals 0. What is the reciprocal to 0? The reciprocal to 0 is not 0. It is undefined. So at all these points for sine, where I had something that was equal to 0, which will always be at the midline of our graph, when I do their reciprocals, they come out to be undefined, and I get vertical asymptotes, just like I did with tangent. Because when the green graph crosses the midline, that's when the y, the sine, is equal to 0. And when I do the reciprocal of 1 over 0, I get something undefined. So I get a vertical asymptote. Now, all these other green points, I could do the reciprocals of. And I'll just do a few of them so we can figure out what the shape is actually going to look like. I'm going to pick a sign that I know is easy to do a reciprocal for. 1/2, right? Your sine value could equal 1/2 if you are which angle in quadrant 1? Sine is 1/2. 30 degrees or pi over 6, right? So pi over 6, like this in my parent graph would have been 0 and pi halves. So pi over 6 is somewhere over here. And let's say this point, this blue point right here, is pi over 6 comma 1/2. Right? Put in the angle pi 6, get the sine value 1/2 back out. Well, if I put in the angle pi 6 to cosecant, I get the reciprocal of that, 1 divided by 1/2. What's the reciprocal to 1/2? 2. Don't overthink this, right? Reciprocal is flipping it. Okay, so the reciprocal to 1/2 is 2, which means this point in cosecant is somewhere way up there. Pi 6, 2. It's outside my frame. What's the reciprocal to this point at the top of my mountain? This value was 1 in the parent graph. What's the reciprocal to 1? Also 1. So the mountain actually shares, the top of the mountain shares a point on my cosecant graph. It's the same. The reciprocal of 1 is 1. But then in quadrant 2, we know that 5 pi 6 would also have a y value of 1/2, right? So here's 1/2, then here's 5 pi 6, 1/2. And if I do the cosecant of 5 pi 6, I'll get 2. So that really shows up there. All these other points are going to flip up. And what you really end up creating is some kind of U-shaped graph trapped in between the vertical asymptotes. It won't be a wave anymore because it can't be connected because of all the places it was equal to 0 and the reciprocal is undefined. When your wave has a mountain high, you have a U that opens up, and they share that point. What do you suppose happens down here in our valley low? It's a U that opens down. It will share this point at -1 because the reciprocal to -1 is -1. There are 2 points down here where the y value, the function value for sine, is -1/2. When we do the reciprocal, those will be at -2, so they'll be down below. So really the thing to note is that whether it's a cosecant or a secant, whether it comes from the sine or the cosine, it's basically no longer a wave. It's U's that open up, U's that open down, and they just alternate, and they have vertical asymptotes in between them. I would not call those parabolas because parabolas don't have asymptotes. So they're just U-shaped graphs. Could you maybe draw in what you think the cosine would look like? Or the secant, reciprocal to cosine? Its asymptotes will be in different spots, right? The asymptotes are formed at the midline because that's when your function equals 0. So I'll have vertical asymptote here, vertical asymptote here. When I'm at maximums, that's the bottom of a U that opens up. When I'm at a minimum, that's the top of a U that opens down. This is the maximum, bottom of a U that opens up. Now, I only draw the half U's because, like, if you really took my picture and copy and pasted, this would finish off that U. I don't take off if people draw full U's at the top, even though that's more than one period. But if you want to draw a whole U, you can. I'll tell you what, I don't really memorize the shapes for cosecant and secant. I already have sine and cosine memorized very well. Mountain high, valley low, right, for sine. And then I just kind of like lightly sketch in what it would look like, and then I swap my U's. Things I will ask you about cosecant and secant. Can you find the period and the starting point? That's going to be 2 pi over b, just like it was for sine and cosine, because that's where they're coming from. And then c over b comma d. Starting point for the frame, not the graph. I'm going to ask you range, which you might already be able to tell. Range is going to be a little bit different because the blue graph, like for the U's that open down, I have some max point, and then there really is nothing in my actual frame, right? And then I get a U that opens up. So I'm going to have like 2 separate intervals for my range. We'll do an example. And then I'm also going to ask you about asymptotes. And of course, you should be able to label the points. So we'll do one example. You guys let me know what kinds of questions you have. And then I will pass back your quizzes from Friday. And, you know, you'll be able to get a good gauge of where you're at. Like, did you have a good quiz on Friday? If you're really strong with sine and cosine, then making the jump to cosecant and secant reasonable. If you struggled on Friday and you're not sure how to do all the parts of framing and graphing for cosine and sine, we maybe have a little bit more work on our plate for cosecant and secant. Let's do y equals -2 cosecant x minus pi over 4. Okay, I want you, and you can talk with your group members if you like, I want you to come up with as much information you know to build that frame. So think about periods, starting points, A values, because that's your vertical spacing. And if you want to start sketching and labeling your frame, go for it. Normally I would do amplitude, period, and starting point. Only sine and cosine, the 2 waves, have amplitudes. Cosecant and secant, they don't have mins and maxes, right? One of the U's is going forever to negative infinity. One of them is going forever to positive infinity. So you can't really have an amplitude half the distance from min to max if you don't have a min and max. So I'll just call it absolute value of A, which is 2, right? That's going to be my vertical spacing. The period, remember, go back to its parent graph sign. So that would be 2 pi over B. And what's our B value? 1. So this is nice. It's just 2 pi. Okay. And then starting point will be C over B comma D. What is C? Sorry? Pi over 4. Excellent. Okay, so C pi over 4 over B is 1, and our D value is 0. Some people are going to see when they get their quizzes back today, like a lot of people, if you looked at that equation, you might have said that C was negative pi fourths. So you got to remember C looks like the opposite. Okay, so it's actually a positive pi fourth, so be on the lookout for that. Okay. That's all really good information because it's going to help me build my frame. I will ask you at the end to do asymptotes and range. So I'm going to add those on there. And I'm going to build my frame. So now I'm going back to my old frame where the starting point is on the left. It's really only tangent that is different. So this means that my y is 0 at the midline and my x is pi fourths down on the left. I can use A as my vertical spacing, so add 2 to 0. That's going to be my max line of my frame, and negative 2. Subtract it. I'm going to use method 2 where I do my spacing for my period. So I'm going to take 2 pi times 1/4, which is 2 pi fourths or pi halves. But since I look at my starting point as a pi fourth, I probably just want to leave it as 2 pi fourths. That'll be really easy to add because they come denominators. So pi fourths plus 2 pi fourths is 3 pi fourths plus 2 pi fourths, 5 pi fourths plus 2 pi fourths, 7 pi fourths plus 2 pi fourths, 9 pi fourths. That's method 2 where I just like keep adding the same spacing. If it's tangent, remember I add it twice and subtract it twice. If you want to do this thing that you might see on your quiz where you check your period, take the last number, 9 pi fourths, and subtract the first number. 9 pi fourths minus pi fourths is 8 pi fourths, which reduces to be 2 pi, which is the period we said we would have. So then we got the spacing right. Okay. The last parts are actually like, now it's pretty easy sailing once I got the spacing. I just have to make sure that I get the right shape so I can label the correct asymptotes. And I usually go off of this. Cosecant is the reciprocal to sine. Sine is normally mountain high, valley low, but it's been reflected here. It's negative. So I know, I usually can do this in my head, but if you want, you can lightly jot it. You're going to do a valley low and a mountain high. So you're going to get your asymptotes on the side, on the left, in the middle, and on the right. Notice I extend my asymptotes beyond my frame because my U's really live outside my frame. And then if it was a normal sign, it would be a U that opens up followed by a U that opens down to match up with mountain high, valley low, but that's been switched around. So I should have a U that opens down and a U that opens up. So they match up with my valley low, mountain high sign. I don't mind if you draw the like original sine or cosine, but just make sure it's light and that you're really drawing the cosecant or the secant so that it's clear you know it's the U's. Okay, so asymptotes, you know, at this point, that'd be pretty easy. I've drawn the asymptotes at pi fourths, 5 pi fourths, and 9 pi fourths. So I'm going to say x equals pi fourths, 5 pi fourths, and 9 pi fourths. Okay, and then range is probably one that will be a little bit different. We're really talking about the range of what I have in blue, the range of the u's. The asymptotes aren't any part of our range because we don't have points there. So like you're always going to have some u's that are going down. Those will start at negative infinity. So you're always going to start at negative infinity with a parenthesis. And then you'll just come up to, it should be whatever the bottom of your frame is, because that's where your max for that u that opens down is going to be. It's going to be at the bottom. So we're going to come up to negative 2. Now, should I use a parenthesis or a bracket there? Is that negative 2 included or excluded? Included, so I would use a bracket. So really, that little piece, negative infinity to negative 2 with a bracket, that's for the u that opens down. And then I use the union, so that just means and. I do a range for the u that opens up. So u that opens up has a minimum, which should be whatever the highest on your frame is, 2, and then goes to positive infinity. Ooh, that looks like a bracket. That should be a parenthesis. Don't judge. So like if we were doing the old sign, the range would have been negative 2 to 2 inside the brackets. But now we're basically using those numbers, and they're going to be paired with the negative infinity and the positive infinity to be the mins and maxes of our u's. Okay. Got any questions for me? Things you want me to clarify? Okay. Then your homework assignment is on the gold sheet. It's the last book assignment, page 317, I think. Here it is. It's got 5 problems, so it's going to be a mix of tangents, cotangents, and cosecants. So now you're graphing all the ones that have asymptotes.